Hello everyone, I'm Ayush Singh from Sri Venkateswara College of Engineering, and in this video we'll be talking about introduction to waste management, component separation, drying and dewatering of waste. We're starting with introduction to waste management. It is the collection, transportation, treatment and disposal of waste. It is a complex process that involves a variety of stakeholders including household, businesses, industries and governments. It is important for protecting human health and the environment. Improper waste management can lead to the spread of disease, water pollution, air pollution and soil contamination. Moving on to component separation, it is a necessary operation in which the waste components are identified and sorted either manually or mechanically to aid further processing. It is required for recovery of valuable materials for recycling, preparation of solid waste by removing certain components prior to incineration, energy recovery, composting, and biogas production. There are several methods of component separation. First one is air separation. This technique has been in use for a number of years in industrial operations for segregating various components from dry mixture. It is primarily used to separate lighter materials from heavier ones. The lighter material may include plastic, paper, and other organic materials. Equipments used for air separation. The first one is conventional chute type. It is one of the simplest type of air classifiers. In this type, when the processed solid waste are dropped into the vertical chute, the lighter material is carried by the airflow to the top, while the heavier materials fall to the bottom of the chute. A rotary air-lock feed mechanism is required to introduce the shredded material into the classifier. Next one is zigzag air classifier. It consists of a continuous vertical column with internal zigzag deflectors through which air is drawn at a high rate. Shaded waste are introduced at the top of the column at a controlled rate and air is introduced at the bottom of the column. As the waste drop into the air stream, the lighter fraction is fluidized and moves upward and out of column, while the heavy fraction falls to the bottom. Third one is open inlet vibrator. In this type of air classifier, the separation is accomplished by a combination of following action. First one is vibration. This helps to stratify the material fed to the separator into heavy and light components. Due to this agitation, the heavy particles tend to settle at the bottom as the shredded waste is conveyed down the length of the separator. Next one is inertial force. In this action, the air pulled in through the feed inlet imparts an inertial acceleration to the lighter particles, while the waste travel down the separator as they are being agitated. Next one is air pressure. This action refers to the injection of fluidizing air into or more high velocity and low mass flow currents across the bed. The final stripping of light particles is accomplished at the point where the heavy fraction discharges from the elutriators. Next one is magnetic separation. The most common method of recovering ferrous scrap from shredded solid waste involves the use of magnetic recovery systems. Ferrous materials are usually recovered either after shredding or before air classification. It is used to remove the ferrous material from the incinerator residue. Magnetic recovery systems have also been used at a landfill disposal sites. Equipment used for magnetic separation. First one is suspended magnet. In this type of separator, a permanent magnet is used to attract the ferrous metal from the waste stream. When the attracted metal reaches the area where there is no magnetism, it falls away freely. The ferrous metal is then collected in a separate container. Second one is magnetic pulley. This consists of a drum type device containing permanent magnets or electromagnets over which a conveyor or a similar transfer mechanism carries the waste stream. The conveyor belt conforms to the rounded shape of the magnetic drum and the magnetic force pulls the ferrous material away from the falling stream of solid waste. Next one is screening. Screening is the most common form of separating solid waste depending on their size by the use of one or more screening surfaces. It has a number of applications in solid waste resource and energy recovery systems. It can be used before or after the shedding and after air separation of waste in various applications dealing with both light and heavy fraction materials. This is a diagram of rotary drum screen. Next, we have other separation techniques: hand sorting or previewing. Previewing of the waste stream and manual removal of large size materials is necessary prior to most types of separation or size reduction techniques. This is done to prevent damage or stoppage of equipment such as shredders or screen due to items such as rugs, pillow, mattress, paint cans, etc. Second is initial separation. Inertial methods rely on a ballistic or gravity separation principles to separate shredded solid waste into light and heavy particles. Third one is flotation. In the flotation process, glass-rich feedstock, which is produced by screening the heavy fraction of the air classified waste after ferrous separation, is immersed in water in a soluble tank. Glass chips, rocks, bricks, bones, and dense plastic materials that sink to the bottom are removed with belt scrapers for further processing. These materials are taken to landfill sites or to incinerators for energy recovery. Fourth is optical sorting. It is used mostly to separate glass from the waste stream, and this can be accomplished by identification of the transparent properties of glass to sort it from opaque materials. In the waste stream, optical sorting involves a compressed air blast that removes or separates the glasses, plain or colored. An optical sorting machinery is, however, complex and expensive. Next, we have drying and dewatering. These operations are used primarily for incineration process with or without energy recovery system. They are also used for drying of sludges in wastewater treatment plants prior to their incineration or transport to land disposal. First, drying. The following three methods are used to apply the heat required for drying the waste. First one is convection drying. In this method, hot air is in direct contact with the solid, wet solid waste stream. Next, second one is conduction drying. In this method, the wet solid waste stream is in contact with a heated surface. Third one is radiation drying. In this method, heat is transmitted directly to the wet solid waste stream by radiation from the heated body. This is the diagram of direct heat rotatory drum dryer. Next we have dewatering. It is most applicable to the problem of sludge disposal from wastewater treatment of plants, but may also be applicable in some cases to municipal industrial waste problems. When drying beds, lagoons, or spreading on land are not feasible, other mechanical means of dewatering are used. The objective is to reduce the liquid volume in the solid waste stream. Once dewatered, the sludge can be mixed with other solid waste and the resulting mixture can be incinerated to reduce volume or used for the production of recoverable byproducts or used for production of compost and buried in a landfill. That's all for this video. If you like our video, do like, share and subscribe.